All right, so to simplify a square root, we made our tree. So what are two things that multiply to 24? 6 and 4, 12 and 2 works. Then we break 6 down and 4 down. So what do we have pairs of?
2.
So we have 2. What did not pair up?
3.
A 2 and a 3. So we go square root 6. 4 is down here in the 2, 2. So we don't want to go back up our tree. We only want to look at the bottom. Okay, so this is what we're doing today. We're going back to simplifying square roots with one difference. They're going to have negatives on the inside. Okay, well, before we do the tree, though, we're going to do something else. We're going to use this definition of I. I stands for the imaginary number, and it's defined as the square root of -1. So when we go to simplify something like the square root of -25, we're going to start by separating the -1 from the 25. Because we can multiply these back together and get square root -25. So we're just going to separate them. Then we can do our tree with what's now positive. So what's our two things that multiply to 25? Okay, so we have a pair of 5s. And then by definition, square root of -1 is the number I. There's your answer. Yeah, so I5. But we say 5I. Really? Okay, that's really all there is to imaginary numbers. Ensley? Okay. So what we're going to practice today is simplifying, as well as when we have I raised to different powers. So let's start with square root of -12. Again, the first thing we're going to do is separate the -1 from the 12. And then with the positive number, we can break down using our tree. So 6 and 2 and 3 and 2. So we have a pair of 2s with a 3 left over. And what's the square root of -1? I. So we go 2I root 3. Hmm?
Why is the I 2 and not?
We usually put it in front of the radical, and it's all being multiplied, so we put it in front of the radical so as not to mistake that it's still inside the square root. Because a lot of times if we write it after, if we put our line too long, we go, oh, the I is inside the square root. No, it's not. So we put it in front just to make sure that confusion doesn't happen. Okay, what about -50? So we separate it, and then what multiplies to 50? 5 and 10, and then 5 and 2. So we have a pair of 5s. What's the square root of -1? So we have 5I square root 2. Okay, what about the square root of -9? And 9. What's the square root of 9?
3.
And then what's the definition of square root -1?
3I.
Okay, so pretty much whenever you see a negative on the inside, you're going to have an I in your answer. Any questions so far?
I'm guessing the homework's nothing wrong.
How do you know? Yes, Ted. Okay, graphing is a totally different thing. We're not graphing. Graphing is just actually like the XY axis, except instead of XY as your axes, you have real, imaginary. So this would be at the ordered pair 0, 3, I.
So it'd be like the same
So, and we don't do graphing here. Y-axis becomes the imaginary axis, and that's where you would graph the imaginary part. And then your real, which we'll see more of that down here with these two, how you'll have two parts to every number, and I'll talk about that in just a second. So let's do this one, because then I can keep answering your question. Ensley?
If I were to say, like, in the square root, like, -1, then what would
Just I.
just I?
Yeah, because square root of -1 is I. Okay, so let's look at 4. 4, we're adding and subtracting. So when we add or subtract, specifically with subtraction, we have to distribute the negative. So we're going to have +2 minus 4i, and then 5 minus 3i. From here, it just becomes combining like terms like we used to. So i's go with i's, whole numbers go with whole numbers. So 7 and -7i. And so every complex number has two parts. This is the real part, the part that doesn't have an I, and this is the imaginary part. Yeah. So if you were to graph this, you'd go 7 on the real axis, which is your x, and then you'd go down 7 on the imaginary. So you graph it very similar to how you do x, y. It's just you call your axes something different.
Is there like a real world like problem that goes with this, like for like a word problem?
A lot of times this is just how we can handle situations. So like, let's say you're a scientist of some sort, and you're trying to see like, can this happen? Well, if you get a negative inside your radical, can it happen? Probably not. So it's more of a way to handle the situations when it doesn't, but there are some fields that actually do utilize the complex number system. They're usually pretty advanced, a little more in the computer science realm, but there are, so it's a little more specific. That's why we're just going to go over how to do the basics, and if you're really interested, go into that field and you can learn all about it. There's a whole set of courses in college called complex analysis. Okay, so what about this one where we're adding? We don't have any distributing. So 7 plus -3 is what? -2i and I, -i. So I just added like terms because we didn't have a negative to distribute, which means we just combined like terms.
So now there's a negative imaginary?
Yeah, they can be negative. So 7 plus -3 is 4. -2i plus I is -1i.
Oh, okay. You should write the 1. Okay.
I just didn't write the 1.
Yeah.
Okay, any questions on simplifying, adding, or subtracting? You sure?
Yeah, I don't need the I. How did it become
This didn't become an I, it had an
How
I.
did it just
Because I added like terms. So what's -2? And this has a 1 in front. So what's -2 plus 1? -1. So it's just like adding like terms, like if it were an X, same thing. Now we're multiplying.
Oh,
You make it sound like it's going to be so much worse than it is. Okay, so if we were to think of I times I, it's I squared. Right? We just add the exponents.
Absolutely.
1, 1, I squared.
The exponents, you mean like the little I, even the little dot on top?
No, that's the dot on the I. Every variable has an exponent. If there isn't one written, remember it defaults to a 1. Okay, so if we substitute what I is the square root of -1 squared. What would that equal?
Nothing.
I squared.
No,
It's the I.
it just be, you know what, I don't know. Wouldn't it be square root of 1?
No, they knock each other out. It's literally -1.
There you go. The square and the square root cancel each other out, leaving you with -1.
So what answer did it?
So imaginary numbers turn into real numbers?
They can, yes.
Oh, man.
All right, so one of the things that we are going to use is that I squared will equal -1. Because if you take the square root of -1 and square it, the squared and the square root cancel out, giving you -1. Huh?
Oh, thank you.
I have one up there. It just doesn't stand up.
Yeah.
It's missing the little foot.
Ooh, I feel the chills in my ear.
Okay. So if we look at ones like number 6, how would we do this if we didn't have imaginary? So you do the same thing. You distribute. So 3i times -5 is -15i.
Are you hot?
No. So this will be 6i squared. But what's I squared equals? I squared equals -1. So what does this become? -6 minus 15i. And there's your answer. Okay, questions on that? How do we get -6? When we multiply,
The negative ones right there.
the I squared becomes -1.
Doesn't matter the order that you write.
So convention says we write the real number first, the imaginary number second. So that's just convention. Okay, so what about 7? We got to double distribute. Okay, so 4 times -1 is -4. 4 times -2i is -8i. 3i times -1 is -3i.
Okay, I'm sorry. Can you slow down a little bit? I'm still very catching up. Like, I'm still writing the problem down.
Stop talking so much and just write.
Well, if I don't say anything,
Okay, so we just double distribute. What does I squared equal? So this will become -6 times -1. What do we have here? Combine like terms, you get -11i. And we bring down the -4. So this, like you guys already said, becomes a +6. So you have like terms here. So 2 minus 11i would be your final answer.